So this is Kishore. Today our topic is quadratic equation. In this chapter, we have a different kind of concepts are there that are all we need to discuss. Before we start the quadratic equation, that I can give you all the information. First one is that definition of quadratic equation. Quadratic equation, and the next one is that all the definition, all the total information about the quadratic equation will be discussed in this form. Next one is that roots of quadratic quadratic equation. Next one is that finding the roots. How to find out the roots? How many roots are there of a quadratic equation? So finding the roots of quadratic equation. Next one is that after finding the quadratic equation, you need to make the relation, right? So what is that? The nature of roots. Based on the roots, how many roots are there? In the sense, what is the meaning of nature? So what kind of the roots will you get down? Whether we'll get the real numbers or whether we'll get the complex number. That means imaginary numbers. Even if you get the real numbers, what kind of the real numbers will you get down? Will you get the quadratic? What is that? Irrational number or rational number? If you get the rational number, what kind of the rational number will you get down? Will you get the equal or non-equal? So that information will be discussed in the nature of the roots. Next one is that what do you have? Next one we can have the relation between roots and coefficients. What is the meaning of coefficient? It's a factor of the term. So first one is the definition of quadratic equation. Next one is the roots of quadratic equation. Finding the third one is finding the roots of quadratic equation. So in this finding the roots of quadratic equation, we have the different kind of methods are there that all will discuss here. The nature of the roots, I already given the information, the minimum information about the nature of the roots. The next one is the relation between the roots and the coefficients. So let us discuss today our topic is quadratic equation. In this one, let us discuss about the definition of quadratic equation, because of most of the students they are confusing about what kind of the form we call it as a quadratic equation. So most of the students they are confusing about the equation and the polynomial. So all that I'll give you demonstration and I'll give you information in this video, so that let us discuss the definition of quadratic equation. Here is that what is the quadratic polynomial? Before discuss the quadratic equation, what is the quadratic polynomial? A quadratic polynomial is a basic algebraic expression in which the highest power of the variable is 2, then it is called as a quadratic polynomial. What is that? How it is in the form? I'll give you. What is that? Here is that ax. What is the highest power where a not equal to 0 and a belongs to real number? What do we call this one? Here is the polynomial in one variable, and you can write down the ax plus b. Here also we have the same, where a comma b belongs to a real number and a not equal to 0. What kind of the polynomial is this? And what is the variable here? A and b, they are not a variables. Here we are considering as a real numbers. So if the a and b are the real numbers, what will we call that? X is the variable. There are these two polynomials will considering as a linear polynomial. What is that? Linear polynomial. Why you will consider linear polynomial? Because of the highest power of the variable is equal to 1, then that polynomial will considered as a linear polynomial. Where do you have the highest power of the variable? Will you considering the power of a? No, because of the variable is x is here and also variable is x is here. So don't confuse that. A is not a variable is here, only x is a variable. I already given that a and b are the real numbers, right? So here is that. So the highest power variable, if you don't have any power, what will you consider? Because of x is only repeated one time, so that indirectly we'll have the power 1, x to the power of 1 here. So the highest power of the variable is equal to 1 in the polynomial, so that the polynomial will correct as a linear polynomial. And the same time, the highest power of the variable numerical coefficient. Here is that. What is the highest power of the variable term? This is the highest power of the variable term. Here is that. Its numerical coefficient. What is that? Its numerical coefficient means number as a coefficient. So where is the, what is the number here? A is the number in that highest power of variable term. So that if a is not equal to 0, then it is called as a linear polynomial. Otherwise, we will call it as a another polynomial. Here is that. Here also same. The highest power of the variable numerical coefficient should not equal to 0. Then only we will call it as a linear polynomial. Next one is that. What is the next? Next one is a quadratic polynomial. Why you need to call it as a quadratic? Quadra means 2, right? So where do you have the 2? Because of and ax square. What is this one? A where a not equal to 0 and a belongs to real number. So that the highest a is not a variable here, x is the variable, right? So that highest power of the variable is equal to, we'll call it as a quadratic polynomial. Yeah. Can you think about that? If it is a linear polynomial, there is a two terms. If it is a linear polynomial, there is a two terms. Better you can write down also one term. Why? Our intention is the highest power of the variable is equal to 1. You should not have more than one highest power is equal to 1, because if you have the 2, highest power of the variable is 2, then it needs to be called as a another polynomial. It should be the lesser than the 1. And one more thing is that, remember, I told you lesser than 1, in the sense only 0, minus 1, minus 2 also will correct as a lesser than 1, but the power of the variable is minus 1, all the negative numbers, then we will not correct as a polynomial. Listen carefully and remember that. So, because of all the power of the variable should be whole numbers, then we will call it as a polynomial. If it is a polynomial, then we can separate the types of polynomial. If it is not a polynomial, we can't separate the polynomial. Right. Here is that ax square is the one term. Will you accept? It is the one term. Right? Why it is a one term? Because of all the terms of the algebraic expressions will be separated by the plus and minus. So that we don't have any plus and we don't have any minus, so that the total expression will considering as a only one term. Very good, right? Here is that a is a real number and where x is the variable, so its highest power is equal to, so that it is called a quadratic polynomial. How many terms are there? Only one. All right. Next one is that ax square plus bx. This is also quadratic polynomial. Why? Our intention is the highest power of the variable term should be 2. Sorry. Yeah. And the condition is a not equal to 0. And what is the condition? A comma b belongs to a real number. Here is that a, b, they are real numbers. So what is the variable in this expression? Here is the x is the one of the variable. So total expression, which is in only one variable. But thing is that their powers will be changed. First term highest power is equal to, second term highest power is equal to 1. Right? So this is also one kind of the quadratic polynomial. Next one is that ax square plus bx plus c, where a not equal to 0, a comma b comma c belongs to real number. Look at here. Here is that ax square plus bx plus c, where a not equal to 0 as well as a, b, c belongs to real number. I told you already, an expression, if it is a polynomial, you need to check up the IS for the variable. What is the variable here? Here is the variable is x. Very good. And what about the a, b, and c? They are the real numbers, right? We'll check it out. The IS for the variable. Here is the variable. Here is the variable. And here we don't have a variable. What will we call that? We'll have the variable, but the variable, its power is equal to 0. That's why any number power 0 is equal to 1. 1 into c. Let us see. Most of the time, the power is equal to 0 of any number, any variable, it is always will be constant in the form of 1. So that's why any power having the 0 of any number will not be existed. That means will not be visible, so that it immediately converting into the 1. Right. Here is that. So this is called as a standard formula. These three forms are called as a quadratic. One is that ax square. This is also quadratic polynomial. Ax square plus bx is also quadratic polynomial. Ax square plus bx plus c is also quadratic polynomial. Why? Because of our intention is is for the variable should be 2. Is for the, what is the degree? The is for the variable in a polynomial is called as a degree of the polynomial. In this is the one polynomial. Why? Variable is a numerator and its power is 2. In this is also one of the polynomial. Why? Every term the variables is numerators, they are in the numerators and their powers are whole number. There is also one kind of the polynomial. This third one is that ax square plus bx plus c. It is also called as a quadratic polynomial, or before that it is a polynomial. Why? All the variables are in a numerator, their powers are whole number. So that this is called as a quadratic polynomials. Here is that linear polynomial. We have the one term linear polynomial, binomial, two terms polynomial in the, we will call it as a binomial. We will have the two kind of linear polynomials. One is the monomial polynomial, another one is the binomial polynomial. We will call it as a linear polynomials, right? Next one is that here is a only one term by quadratic polynomial is there. This is called as a quadratic polynomial. Quadratic polynomial, right? Here is that highest power of the variable is equal to, so let's say quadratic polynomial. How many terms do you have here? Only one. Ax square is only one term. Next one is that ax square plus bx. How many terms do you have here? Two terms are there. But thing is that even if you have one term, even if you have the two terms or three terms, you should see about the highest power of the variable. Whether we have the two or not. If you have the two, we'll call it as a quadratic polynomial. Right? Here also it's called as a quadratic polynomial. This third one also we have the three terms are there. 1, 2, 3. Three terms are there. Highest power is equal to, so that is also quadratic polynomial. So basically the types of the polynomials is depending on the highest power of the variable. The highest power of the variable is equal to 1, we will call it as the linear polynomial. If the highest power of the variable is equal to 2, we will call it as a quadratic polynomial. I think everyone understood this concept about the quadratic polynomial. Now, let us discuss about the quadratic equation. What do we call the quadratic equation? Quadratic equation. So, what is the standard form? I told you just now, ax square plus bx plus c is a quadratic polynomial. So, what is the equation? Now, normally, everyone knows that because we have been learning from the 6th grade. So we have the equation LHS is equal to RHS, we will call it as a equation. So if we don't know anything to equate it, we can just make it as a 0. If it is equal to 0, so the quadratic polynomial, if it is equal to 0, we will call it as a quadratic equation, right? Here is that and the condition is a not equal to 0. Next one is that a, b, c belongs to a real number, right? These three numerical coefficients are real numbers, and the highest power of the variable numerical coefficient should not equal to 0. This is called as a quadratic equation standard formula. Standard form. Right. Right. The thing is that I'll give you one question. I have one doubt. Can anyone say that? Yeah. X squared plus 1x. Will you call it as a quadratic polynomial? First, let us discuss about the quadratic polynomial. If it is equal to 0, it is called a quadratic equation. It's not a problem to find out the quadratic equation. But thing is that before, whenever you get the polynomial, quadratic polynomial, or else if they give you any expression to check whether it is a quadratic polynomial or not, first think about that highest power, and also think about that the variables whether they are a numerator or a denominator. If they are then they are in a numerator, or else if it is a denominator, you need to make converting into the numerator. See here is that x square plus and 1 by x. Can you write down as a reciprocal? If it is write as a reciprocal, then power should be the minus 1. Now check it out. I told you already the power of the variables in every term should be whole number. So what is the power of the variable is here? 2. What is the power of the variable is here? Minus 1. I told you already to call it as a quadratic polynomial, the power of the variable should be the whole number. Here is a 2, here is a minus 1. Are they the whole numbers? No. 2 belongs to whole number. 2 belongs to whole number. But minus 1 does not belong to whole number. So if it is one variable power is not a whole number, the given expression is not a quadratic polynomial, not a quadratic polynomial, right? Quadratic polynomial. Same concept, we will take it in a equation. What happened? We'll check it out. See, if it is a say x square plus 1 by x is equal to 0, what happened here? This is a polynomial. This is the equation, right? So before, whenever we are given the expression, you need to be panic to solve the question. So before you solve that, first you analyze it and observe carefully whether it is a polynomial or not. If it is not a polynomial, there is a chance to converting into the what is the simplification, right? So before you transport that, I need to do the cross multiplication. X into x square, x to the power of 3 plus numerator by denominator is equal to 0. Thereafter, I have the addition of two expressions or two what is that algebraic expression. I have done simplification. After completing the simplification, then you can do the cross multiplication. What is in here? X cube plus 1 is equal to 0 and x 0. So now this is the equation. Can we call it as a quadratic polynomial? No. Why? So here is that I told you already the highest power of the variable should be 2. What is the highest power of the variable? 3 is here. If it is a 3, will you call it as a quadratic? No. If it is a 2, will call it as a quadratic. Right? So it is not a quadratic. Not a quadratic. Not a quadratic polynomial. Right? I think everyone understood. If you have any problem, please let me know that. Or else please send your send your views in a chat. Right? Next one is that. I'll give one more example. Right? Next one is that x plus 1 by x. This is also, observe that I have removed the power 2. Then will you call it as a quadratic polynomial? No, because of x plus x to the power of minus 1. Here is the power is equal to 1. It's a whole number, but power is equal to minus 1. It is not a whole number, so that minus 1 does not whole number, so that it is not a quadratic polynomial. Actually, it is not a polynomial. First one, right? Not a polynomial. Very good. Next one is that same situation I can give you based on the equation x plus 1 by x is equal to 0. What is that? Can you call it as a quadratic polynomial? No, don't be panic because of it is when you look at that we already discussed it. It's not a polynomial and don't confuse that. It is a polynomial. Yes, will you call it as a polynomial? No, it is not a polynomial, but it is in the form of equation, right? So that equation we need to simplify before you what is that to express your view based on the quadratic polynomial or not, right? Let us what is that? Do the simplification. X into x square plus 1 by numerator. Do the cross multiplication. Actually, before we need to do the fraction. These are the two kind of fractions. We do the LCM and everything. Instead of doing the LCM, we do the cross multiplication. Numerator into denominator. Whatever the application is there, that you need to apply. Same like a improper. How we are converting into the improper fraction into the mixed fraction into the improper fraction. We'll do the same here. But improper mixed fraction into the improper fraction will do numerator into denominator into whole number plus numerator by denominator. That will convert the fraction mixed fraction into the improper. But whereas here, whenever you are doing the addition or subtraction of the what is that fractions, so you do the same. But the thing is that not always positive. Whatever the symbol is here, that we can calculate it here. So denominator into whole number plus numerator by denominator is equal to 0. Then do cross multiplication. After doing the simplification, after getting the only one expression, here is the two expressions are there. There are the two terms. So make it as a one term. After that, we can do the cross multiplication. X square plus 1, 0 into x 0. Now we can check it out. Can you call it as a quadratic polynomial? Can you call it as a quadratic equation here? First thing is that let us discuss about the quadratic polynomial. If it is equal to 0, it's an equation. There is no doubt at all. But thing is that whether it is a quadratic polynomial or not. Yes? No. Okay, chalo. We'll discuss here. Here is that is for the variable. What is is for the variable here? 2. Obviously, the is for the variable is equal to 2. So that means degree is equal to 2. So that it is called as a quadratic. Is a polynomial or equation. Equation y is equal to 0. Say quadratic equation. Have you understood, everyone? So this is called as a quadratic equation because of every term they won't give you direct information about the quadratic polynomial as well as quadratic. But the polynomial you can easily to say that. But the equation, whenever they have given the equation to say, to define, to confirm, to verify whether it is a quadratic equation or not. So first you need to check out, or first you need to give in that to simplify. After that you can give the your opinion. And next one is that how many roots do you have here? How many roots do you have here?